Hello students, welcome back to online classes. In last session we discussed about the hydrogen as well as the binary compounds of a hydrogen, that is hydrous. So now we will discuss about the further part, so that is water. So in Earth the 75% is made up of water, and in human body more than 65% it consists water, and in plants more than 95% water is present. It is the major source for all living organisms which are present in the environment. So the sum of the properties of water is it is polar in nature. Firstly, it is polar in nature and it has high dielectric constant as well as high dipole moment, and it has high heat of vaporization and heat of capacity. As a result of that, human body is adjusted with the moderate temperature in the environment, as well as it shows high density of about 1 gram per ml at 4 degrees centigrade. It is showing high density of about 1 gram per mmol at 4 degrees centigrade, because at increasing temperature the hydrogen molecules or also hydrogen bond which is present in the water molecule, which will come close to each other. As a result of that, in the initial stage the density should be increases up to 4 degrees centigrade. Whenever we are increasing the temperature, the water molecules are come close to each other due to presence of. So it is showing maximum density of about 1 gram per ml at 4 degrees centigrade, because at increased temperature the water molecules are come close to each other. As a result, density increases, but upon increasing temperature after 4 degrees centigrade, further if we increases the temperature, the water molecules will move away from each other. As a result, the density should be decreases. As a result, the water should have maximum density at about 4 degrees centigrade only. So if we see the structure of water in a gaseous phase, it has bent shape. In gaseous phase, the water molecule has bent shape and having bond angle 104 degree 5 minutes, and the bond length which is present between oxygen to hydrogen is about 95 picom. So in gaseous phase, the water molecule is having the bent shape. If we consider the shape of a molecule, it is bent. But if we consider the geometry of the water molecule, it is tetrahedral. Okay, the shape of the water molecule is bent, but geometry is tetrahedral. So we can say geometry as well as shape of a molecule by counting lone pair as well as the bond pair. If we consider only bond pair present in the molecule, we will get shape only. If we consider the total number of lone pairs as well as bond pair, we will get the geometry of a molecule. So already you know about the DSCPR theory. So in the theory, it tells the total number of lone pair and bond pair will tells about the geometry of a molecule, and the bond pair will gives the information about the shape of a molecule. If we see the hybridized structure of water molecule, so water is having sp3 hybridization, means sp3 hybridization, H2O, here central atom is oxygen. So the water molecule has sp3 hybridization. As a result of sp3 hybridization, it will generate 4 identical hybrid orbitals. So those are 4 identical sp3 hybrid orbitals. So each oxygen initially surrounded by the 4 identical hybrid orbitals. Out of 4, 2 will have 1 electron, and remaining 2 hybrid orbitals are having lone pair of electrons, means paired electrons. So out of 4, 2 of the hybrid orbitals of oxygen overlap with the s orbital of hydrogen. So s orbital of hydrogen contains 1 electron. So that is why they will make hydrogen bonding with oxygen molecule. Means head to head overlap will gives the sigma bonding, and here also one more sp3 hydrogen of oxygen will overlap with the s orbital of hydrogen. Again in head to head manner it will give one more sigma bonding in the water molecule. In this way, two hydrogen atoms are bonded with the two sp3 hydrogen of oxygen will give two sigma bonds here. But further, the remaining hydrogen atoms they will not participate in the bonding. Means there are no further hydrogens. Only water molecule contains two hydrogens. Those are involved in the bonding. But further, there are no hydrogens. Since these two sp3 hydrogen will be behave as a non-bonding electrons or a lone pair of electrons. This will behave as a non-bonding or a lone pair of electrons. So that's why the water molecule has two lone pair of electrons and two bond pairs. So if you consider the shape of a molecule with respect to bond pair, it has band shape. If we consider total number of lone pair as well as bond pair, is geometry will become tetrahedral. The water molecule has two lone pair and two bond pair. The hybridization of the water molecule is sp3 hybridization. As a result of presence of lone pair of electrons, the bond angle is decreases from 109 degree to 104. Usually, the tetrahedral molecules are having 109 degree angle, but due to presence of these bond pair of electrons, they will undergo repulsion from that of the bond pairs, since the bond angle is decreases from 109 to 104. So this is about the structure of a water molecule. Means it has band shape, as well as if we consider geometry, it has the tetrahedral geometry. So next is ice. So water shows unusual properties. It is exist in liquid form as a water, in solid form it is exist in ice, because it is. So ice is the crystalline form of a water, and it has a hexagonal structure in a atmospheric pressure, and it is exist in fluid form in a low temperature. But X-ray studies show that each oxygen in a water molecule, it is surrounded by tetrahedrally with other 4 oxygen atoms at a distance 276 picometer. So ice has lesser density compared to that of a water molecule. So that is why the ice will close on the surface of a water. The ice has the lesser density compared to water, since it is close on the surface of a water. So if you move towards the chemical properties of water, it is more reactive with many elements. This water is showing many chemical reactions with the number of elements, but out of those we have 4 important chemical properties. One is the amphoteric nature of water. So water will showing amphoteric nature. And second property is it is showing redox reaction. And third property is hydrolysis reaction. And the fourth property is hydrating nature. Hydrating nature of water. So these are the 4 important properties of water. So amphoteric behavior, redox behavior, hydrolysis nature, as well as hydrating nature of water. So in that, first one is amphoteric nature of water. So amphoteric nature is nothing but the water will behave as a both acid and base. So that is considered as a amphoteric behavior. So if the species will behave as a both acid and base, then it is said to water will show that kind of a nature since it is considered as a amphiteric behavior of a water. For example, so water when it is reacts with the aqueous ammonia, water when this reacts with the aqueous ammonia, by donating protons to ammonia, it will behave as a acid here. So by donating proton, it will behave as a acid here, Bronsted acid. So Bronsted acid is nothing but the acid which has capacity to donate the proton. So here the water molecule will donate one proton to ammonia molecule. As a result, it will behave as the Bronsted acid here. So this is the reversible reaction. So next, it will behave as a base by accepting proton from hydrogen sulfide. By accepting proton from hydrogen sulfide, it will behave as a base, Bronsted base. So in the first reaction, it will behave as a acid by donating proton to ammonia. So NH3 will convert into NH4, that is quaternary ammonium ion or as a ammonium ion. And in second reaction, water will be behaving as a base by accepting the proton from. So in second reaction, it will behave as a base by reacting with the hydrogen sulfide by accepting proton from the hydrogen sulfide. So in this way, it is showing amphiteric nature, means it is act as a both acid as well as the base. By with this, if you write the neutralization reaction or as a auto-ionization reaction. So auto-ionization reaction means itself undergoing ionization. So that is considered as a auto-ionization reaction. So we can write it as H2O or else 2H2O molecules. We can write simply 2H2O molecules. We will get the formation of H3O plus and OH minus. So initially we can write it as acid 1 and base 2. So after reaction, this H3O molecule will behave as a conjugate acid of acid 1 and OH minus will behave as a conjugate base of second order molecule, that is base 2. So in this way, water will show the both acid and basic characters since it is said to be amphiteric behavior of water. So this is the important one. So next, it is showing redox reactions. Means redox reaction means it is showing both oxidation reaction as well as a reduction reaction. So the redox reaction. Water will undergo easily reduced into liberation of hydrogen by treating with most of the more electropositive elements like sodium, potassium or as lithium elements, usually alkali metals. Whenever water reacts with the alkali metals or as electropositive metals, it should undergo reduction or else it is reduced into hydrogen. So we can write it as 2H2O. Whenever it is reacts with the more electropositive elements like sodium or as potassium. So in general, I will write sodium. So it will form sodium hydroxide with the liberation of hydrogen. So in this way, water should undergo reduction. So if it is reacted with chlorine, means more electronegative, it is undergo oxidation. So for example, water molecule is associated with the chlorine gas, then we are going to get the formation of oxidizing form of water, that is it will liberate oxygen. So whenever we oxidation in the photosynthesis process. Photosynthesis process is the one of the best example for the oxidation behavior of water. So when carbon dioxide reacts with water, it will produce the formation of a glucose or else carbohydrate with the liberation of oxygen molecule. So in this way, water will behave as in this way, water will show both oxidation as well as the reduction property, since it is considered as the redox behavior of water. So these are the example for reduction reaction as well as the oxidation reaction. And the third one is the hydrolysis nature of water. So water is polar in nature, so that is why most of the covalent compounds and ionic compounds are soluble in the water and it will form many of the reactions. So whenever the phosphorus pentoxide reacts with the water molecule, means it should undergo hydrolysis into orthophosphoric acid. The phosphorus pentoxide, if it is undergo hydrolysis with water, it will use the formation of orthophosphoric acid. So one more example is the covalent compound, that is silicon tetrachloride undergo hydrolysis with water and gives the formation of silica and liberation of hydrogen peroxide will be taken place. So in this way, the water will show the hydrolysis reaction because of its polar nature and it has more dielectric constant as well as the more dipole moment. The fourth reaction of water is hydrating nature. The last property is hydrating property. So that is the aqueous solutions of water will form or it will crystallize into hydrated salts like chlorinated water, interstitial water. So these are the example for the chlorinated water as well as the interstitial water. So these are the four important properties of water. One is the amphoteric behavior, the redox behavior as well as the hydrolysis behavior, and the fourth one is the hydrating property of water. So this is about the properties. So next is the types of water. So mainly there are two types. One is hard water and another one is the soft water. If calcium and magnesium salts which are present in the form of hydrocarbonates, sulfates or else chlorides, so that water is said to be harder or else hard water. If the salts like the calcium, magnesium, sulfates, chlorides or else hydrocarbonates, if they are present in a water, then that kind of water is said to be harder water. And if water is free from that of the calcium and magnesium salts, then those are said to be the soft water. So hard water does not give the foam or lather with the soap, because the calcium and magnesium salts which are present in the water, they will react with the sodium citrate which is present in soap. It will form the precipitation. As a result of precipitation, you will not get the soap here. And moreover, these salts which are present in water, they will be deposited in the form of a scale. So that's why this water, hard water, is not useful for the laundry purpose. Means it will not give the any soap, as well as if you have used this water for the boiler purpose, then the efficiency of boiler is also reduced, because the deposition of salts will be taken place in the form of a scale, since hard water is unsuitable for the laundry. And we will remove hardness of water by two methods. One is temporary method and another one is the permanent method. So in the first one is temporary method. We will remove the hardness of water temporarily. So that method is going to be temporary method. Here we are having two types. One is boiling method and another one is Clark's method. So we can remove hardness of water temporarily by two methods. One is boiling and another one is Clark's method. So in case of boiling, we can eliminate the calcium hydrocarbonate as well as the magnesium hydrocarbonate if the salts are present in the form of hydrocarbonates only. So we can remove that hardness of water by using boiling method. Means here we are boiling the water and we are converted into the magnesium carbonates into the magnesium hydroxides which are insoluble. By converting magnesium carbonates into insoluble magnesium hydroxide and the calcium carbonates into calcium carbonates. Calcium bicarbonates into converting magnesium hydrogen carbonate into magnesium hydroxide, calcium hydrogen carbonate into calcium carbonate. So these are precipitate. So this precipitation will be removed by the help of filtration method and the filtrate now it contains soft water. So in this way, by boiling the water temporarily, we can remove the magnesium and calcium salts if they are exist in carbonate form. We can easily remove by the help of a boiling method. So another method is the Clark method. Here, by adding the calculated amount of lime. So by adding the calculated amount of lime to that of hot water, we can remove the hardness of water. So here also the calcium hydrocarbonates when they react with the lime, that is into calcium hydroxide, they will form calcium carbonate precipitation and the magnesium hydroxide precipitate. So these calcium as well as the magnesium hydroxide precipitate will be filtered out. Again the filter contains the salt form. So in this way the Clark method is useful for the removal of hardness of the water by eliminating magnesium hydroxide as well as the calcium carbonate from the water. So Clark method is nothing but we have to add the calculated amount of lime to the hard water. Then it will remove the calcium hydrocarbonate into, it will convert calcium hydrocarbonate into calcium carbonate and the magnesium hydrocarbonate into magnesium hydroxide. So these will exist in the form of precipitate. So this will be removed by the filtration method again. The filtrate contains the pure water called as a soft water. In this way, we can remove hardness of water temporarily by using boiling method as well as the Clark's method. So these are the temporary methods. And next is we can remove hardness of water by permanent method. Means we can remove hardness of water by permanently. It is due to the presence of soluble salts of magnesium and calcium in the form of chlorides and sulfates in water. Means if water contains magnesium and calcium salts in the form of hydrocarbonates, we can remove temporarily. If water has magnesium and calcium salts in the form of sulfates and chlorides, we have to remove permanent method by not using the boiling method. We cannot remove these salts by using simply boiling the water. So we have to use the permanent methods like ion exchange method, synthetic resin methods, Kaljan's method, as well as by treating with washing soda. So we can use all these four processes to remove the hardness of water by permanently. In that, first one is the treatment with washing soda. These are the permanent methods to remove hardness of the water. In that, first one is by treating with washing soda. So washing soda is nothing but sodium carbonate. Disodium carbonate is called as the washing soda. So when the calcium or magnesium chloride, if they are treated with the washing soda, we can eliminate them in the form of a metal carbonates. Here M may be calcium or else magnesium. So initially it is present in the form of chloride, but after treating with the washing soda, we are converting them into carbonates. Now it is easy to remove them. So if they are existing sulfates form, that is one is of food. So they will also converted into metal carbonates, precipitation. Then they will be removed and the water will become soft. Here the may be calcium or also magnesium. So by treating with the washing soda, it will react with soluble calcium and magnesium chlorides and sulfates in the hard water to form insoluble carbonates. So this is about the permanent method for removal of hardness of the water. So next is the Kaljan's method. The sodium hexametaphosphate is commercially called as a Kaljan. So we can remove hardness of water by adding Kaljan to the hard water. So this is the second method. Kaljan is nothing but sodium hexametaphosphate. By adding sodium hexametaphosphate are also collagens to hard water, it will remove the hardness of water. Firstly, it should undergo ionization, reduce anion, so this anion is reacts with the salts which are present in the hard water, means magnesium or also calcium salts. Then it will form complex anion. So this complex anion will hold up the salt seal. So in this way we can remove the hardness of the water by using Kaljan's method. So this is the Kaljan method. So this complex ion will hold up the metal. So that is nothing but magnesium or else calcium. So in this way, by Kaljan method we can remove the hardness of water. And next one is the ion exchange method. third one is ion exchange method. So as the name indicates, here in this method, the calcium or magnesium ions are exchanged by the some of the other ions. Here usually we are using zeolite as the for the removal of the hardness of the water. So it is usually called sodium aluminum silicate. So that is the zeolite usually called as sodium aluminum silicate here. In ionization method we are using zeolite, so that is sodium aluminum silicate. So where Z indicates the zeolite. So this is useful for the removal of hardness of water. By treating the zeolites with hard water, it will react with the metals of magnesium as well as the calcium. Then they will pick up the metal with zeolite and they will release sodium in the water. As a result of that, the water will become soft. The zeolite will pick up only the calcium or magnesium which is present in the hard water. Then it will make the water softer. So in this way we can remove hardness of water by ion exchange method by using zeolites. And the fourth or last method is the synthetic resin method. So this is the more efficient method than that of the ion exchange method. So rather than that of using zeolite, by synthetic resin method we can remove the hardness of water. So here we are using resins to remove the hardness of water. So here we have two types. One is cation exchange resin method and another one is anion exchange resins. So cation exchange resins are always exchange the cations from other solvent moiety, and anions will exchange the other anions like chlorine, sulfates as well as the chlorides which are exist in the hard water. So in this way we can remove hardness of water by using the resin technique. So where R indicates the resin here. So in this way we can remove the hardness of water by using resin technique. In the cation exchange process, hydrogen exchange for sodium plus ion, calcium ion, magnesium ion and other cations which are present in the water. So this process will result in the proton and this will make water acidic. So in this way we can use these four methods to remove the hardness of water. The first one is by treating with washing soda, second one is the Calgen's method, and the third one is by using ionization method, and fourth one is the synthetic resin method. So these are the four permanent methods to remove the hardness of water. So this is about the water as well as the types of water and the chemical properties of water. So in next session we will discuss about the further. Thank you all.